So now we'll begin with the level 2 section of the chapter binomial distribution. The question is x belongs to a binomial distribution where n is 6. So n is given as 6. Probability p is given as 0.3, that is 3 by 10. And it is given that 0.3 raised to 6 is 0.000729. We have to find probability of x less than equal to 4. Now let us find the general probability. P of x equals r is NCR p raised to r q raised to n minus r. So here r is we'll find the general form. So n is here 6 CR, p is 3 by 10. So q is 1 minus p, that is 1 minus 0.3, which is 0.7. So q is 0.7. So 7 by 10 raised to 6 minus r. So that is equal to 1 by 10 raised to 6 CR, 3 raised to r, 7 raised to 6 minus r. So this is the general form for probability x equals r. So now p of x less than equal to r is 1 minus p of x equals 5 plus p of x equals 6, that is 1 minus none property. So this will be 1 minus, this is the total probability, which is 1. So 1 of x equals 5, so r is 5 in this case. So this is 1 by 10 raised to r, 1 by 10 raised to 6. We take this term common. So 1 by 10 raised to 6 is common. So 6 CR, that is 65. 3 raised to r, that is 5, into 7 raised to 6 minus 5. Plus here r is 6, so 6C6, 3 raised to 6 into 7 raised to 6 minus 6. That is 1 minus 1 by 10 raised to 6 into, now we take 3 raised to 5 common in within these brackets. So this is 3 raised to 5, 65 6 into 7 raised to 6 minus 5 is 7 raised to 1, which is 7. So 6 into 7 plus 3 into 1. 7 raised to 6 minus 6 is 7 raised to 0, which is 1. So this is 1 minus 1 by 10, 3 raised to 5 into 3 raised to 5 into 45. This is 45. We can write this as 15 into 3 and bring this 3 along with 3 raised to 5. So we get 1 minus 1 by 10 raised to 6, 3 raised to 6 into 15. That is 1 minus 3 by 10 raised to 6 into 15. Now we have 3 by 10 raised to 15, which is given. So this is equal to 1 minus 0.00729 into 15. So this is equal to 1 minus 0.0109 approximately, which is equal to 0.989, which is option C. Next question is, a man takes a step forward with probability 0.4 and backward with probability 0.6. Probability that at the end of 11 steps, he is 1 step away from the starting point is, so it is given that 0.24 is to 5 is 0.0008. So it is given that a man is moving and probability of moving forward is 0.4 and probability for moving backward, which is Q, that is 1 minus P, is 0.6. So we have to find the probability that he is 1 step away from the starting point. So it can be either backward, 1 step backward, or 1 step forward, and this is the starting point. So this is possible when he moves 6 steps forwards and 5 steps backwards. 6 steps forwards and 5 steps backwards, or 6 steps backwards or 5 steps forwards. That is, this can be written as P of probability of x equals 5, since x is the probability of moving forward. So here we have 5 forward steps and 6 backward steps, or probability of x equals 6, where we take 6 forward steps. So the total probability will be p of x will be p of x equals 6 plus p of x equals 5. Plus is for OR condition, where it can be either of the case. So this condition is for when the person is one step away from the forward, one step away from the starting point in forward direction, and this is for one step away in backward direction. So p of x equals 6 is the standard rule, NCR p raised to r q raised to n minus r. So it will be n is total number of steps is 11. So n is 11. So 11c6 p is p raised to 6 q raised to 5 plus 11c5 p raised to 5 q raised to 6. So here we can take few things common. 11c6 is the same as 11c5 since NCR is the same as NCn minus r. That is 11c6 is equal to 11c 11 minus 6, which is 11c5. So this we can take this common, p raised to 5 and q raised to 5 common. So this will be 11c5 p raised to 6 into q raised to 5 plus p raised to 5 into q raised to 6. So 11c5 is 11 into 10 into 9 into 8 into 7 divided by 5 into 4 into 3 into 2 into 1. P is 0.4 raised to 6 into 0.6 raised to 5 plus 0.4 raised to 5 into 0.6 raised to 6. This is equal to, this can be simplified into 11 into 2 into 3 into 7 into 0.24 raised to 5. Now 0.24 raised to 5 is given. So the final form is 462 into 0.0008, which is approximately 0.3696, which is approximately 0.37, which is option A. Probability is 0.37. Next question is, if n biscuits are distributed among n boys, capital N boys, at random, then probability that a particular boy gets r number of biscuits is, where r is less than 9. So we have to find the probability that a boy in a group of n, let this be n number, gets r number of biscuits. So number of tries, that is number of biscuits, is n. So n is n. Probability that a boy gets a biscuit is, now one boy, we are checking that if one boy gets a biscuit, so it is one boy, 1% divided by total number of boys, that is 1. So probability that a boy will get a biscuit is number 1, that is the boy, divided by total number of boys. So probability is 1 by 9, since he'll be getting a biscuit among n boys. So probability that a boy gets a biscuit is 1 by n. So q will be 1 minus p, which is 1 minus 1 by n. So q will be n minus 1 by n. So p is 1 by n and q is n minus 1 by n. So probability of x equals r is, where r is number of biscuits and this is less than n. So this will be NCR p raised to r q raised to n minus r. So this will be NCR, p is 1 by n, so 1 by n raised to r, n minus 1 by n raised to n minus r, which is option C. It is given that x belongs to binomial distribution where n is 8, p is 0.5, that is half. Naturally q will be also half. We have to find the probability that mod of x minus 4 is less than equal to 2. So first we have to simplify this expression. So mod of x minus 4 is less than equal to 2. So mod of x minus 4 is this, removing the mods, we can say this is less than minus 2 and greater than minus 2 and less than 2, since we are removing the mods. So x minus 4 lies between minus 2 and 2. For example, we take a value like 3. So if we put 3 in the bracket, so this will be greater than 2, so it won't satisfy. Similarly, if we take minus 3, so mod of minus 3 will be 3. So again, it will be greater than 2, which will not satisfy. So only numbers which will satisfy is numbers which satisfy will be numbers which are equal to 2 or minus 2, or the numbers lying between minus 2 and 2. Anything beyond that will not satisfy the equation. So x minus 4 will lie between minus 2 and 2. So we bring this 4 to both sides. It's like an equation. So this will be minus 2 plus 4 is less than equal to x less than equal to 2 plus 4. So this will be 2 greater than less than equal to x less than equal to 6. So we can say x lies between 2 to 6. So we found a probability range. So we can say P of mod of x minus 4 is less than 2 is equal to P of 2 less than equal to x less than equal to 6. So n is 8. So you can write this as, now among 8 trials, so there are 8 trials. We have to find the probability between 2 to 6. So using 1 minus none property, this will be equal to probability 2 less than equal to x less than equal to 6 will be 1, that is total probability, minus probability of the remaining, that is P of 1 plus P of 7 plus P of 8, that is the remaining probabilities. So we apply the formula. So this will be 1 minus 8C0. Now since probability is half, so P into Q will be P raised to R into Q raised to R will n minus R will be, since P and Q are same, so it will be half raised to R into half raised to n minus R, which will be the same as half raised to n. So this will be common in all the terms as we have seen in the previous terms. So we'll be taking half raised to n common throughout the expressions. So n in this case is n, so this will be half raised to 8. So half raised to 8 is common. This is P raised to R, Q raised to n minus R into, now only thing which is remaining is NCR. So R for this is 1. Also this will also include P of 0. So this will be NC0, that is 8C0 plus 8C1 plus 8C7 plus 8C8. So 1 minus half raised to 8. 8C0 is 1 plus 8C1 is 8 plus 8C7 is also 8 plus 8C8 is 1. So this will be 1 minus half raised to 8 into 1 plus 8 plus 8 plus 1. So this is 18. So simplifying this, we'll get 1 minus 9 by 128, which will be equal to 119 by 128, which is option A. if in n tosses, probability of getting a head at least once is greater than equal to 0.9, then n is what? We have to find the value of n. It is given that in n tosses, probability of getting at least one head is greater than equal to 0.9. That is p of, so at least one head. So this will be x, where x is probability of getting a head. So x will be greater than equal to 1. And this is greater than equal to 0.9. So now this can be written as probability of getting at least one head is total probability minus probability of getting no head. That is p of x equals 0. So this is greater than equal to 0.9. So p of x equals 0 is 1 minus, now p, since we are assuming it to be a fair coin, so p, small p will be half and q will be also half. So therefore, using the formula, we can say this is p of x equals 0 is NCR p raised to r q raised to n minus r is greater than equal to 0.9. So 1 minus n is, so this will be n as it is. C, r is 0 in this case. P raised to 0, q raised to n minus 0 is greater than equal to 0.9. So NC0 is 1, anything with combination of 0 is 1. So 1 minus 1 into p raised to 0 is 1, and this is also n minus 0. So this will be 1 into 1 into q raised to n is greater than equal to 0.9. Q is half, so this will be 1 minus half raised to n is greater than equal to 0.9. So adjusting the terms, we can say 1 minus 0.9 is greater than equal to half raised to n, bringing this term to RHS and this to LHS. So half raised to n will be less than equal to 1 minus 0.9 is, okay, 1 minus 0.9 is 0.1. So 0.1 will be greater than equal to half raised to n. So therefore, we can say 2 raised to n will be, since we can write this as 1 raised to n upon 2 raised to n, so bring this term on the LHS and this to RHS. This will be greater than equal to 1 by 0.1, that is equal to 10, since reciprocal of 0.1 is 10. So 2 raised to 10 is greater than 10. So 2 raised to n is greater than equal to 10. So n is such that the power of 2 is greater than 10. So 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 2 is 3, 2 raised to 2 is 4, 2 raised to 3 is 8, and 2 raised to 4 is 16. So you can see right from 4, it is greater than 10. So for n equals 4, starting from n equals 4, it starts getting greater than 10. So the least value of n will be, least value of n is 16, which is greater than 10. So therefore n is equal to 4, which is the least value, since 16 is 2 raised to 4 and 4 should be such that 2 raised to n is greater than equal to 10. So the answer is 4, which is option B. Next question is, suppose x belongs to binomial n comma p where 0 is less than p is less than 1. Ratio p of x equals r to ratio of p equals x equals n minus r is independent of n and r. Then the value of p is what? So we are given that ratio of p x equals r upon p of x equals n minus r is independent of n and r. This means whatever the value of n and r, for whatever value of n and r, the ratio will remain constant. So let us apply the formula. So this will be NCR, that is NCR into P raised to R Q raised to N minus R, standard formula. And P of X equals N minus R will be NC, R will be replaced by N minus R, so NC N minus R, P raised to N minus R, Q raised to N minus bracket of N minus R. Now Q is 1 minus P, substituting this and simplifying it, so NCR P raised to R 1 minus P raised to N minus R upon NC N minus R to P raised to N minus R. N minus R is N minus N gets cancelled, so this is R, just R, so 1 minus P, Q is 1 minus P raised to just R. So by property of combination, NCR is equal to NC N minus R. So this term gets cancelled. Rearranging the terms, that is rearranging the powers of P and 1 minus P, we can write 1 minus P raised to N minus 2R, that is N minus R upon P raised to N minus 2R, that is N minus R, and this is equal to the ratio P of X equals R, P of X equals N minus R. That is constant, which is equal to 1 minus P by P raised to N minus 2R. Now this term is supposed to be a constant. That is, whatever the power is, the whole term will be constant, and this is only possible if this bracket is 1. Since anything 1 raised to anything is constant, that is 1. So that is only possible if this is 1. So if this is 1, if this is say 3, answer will be 1. If this is 4, answer will be again 1. So the power won't change. The answer won't change even if the power changes. So 1 minus P by P should be 1 for this to be independent. So 1 minus P by P is 1 for independence of this term. So therefore P will be 1 minus P will be P. Therefore 1 equals to P. Therefore P equals half. So the value of P is B, half. Number of times a fair coin must be tossed so that the probability of getting at least one head is at least 0.95s. So let the number of tosses be n. So we have to find the condition is probability that at least we get at least one head, and this should be at least 0.95. So P of X, where X is getting probability of getting head, and we assuming it to be a fair coin, so P will be half and Q will be half. So P of X equals X greater than equals 1 is greater than equal to 0.95, that is at least 0.95. So X is greater than equal to half is the same as 1 minus P of X equals 0, that is 1 minus none property. So this will be greater than equal to 0.95. So P of X equals 0, so we apply the formula. So this will be 1 minus P of X equals 0 is NCR, that is NC0, P raised to R, that is half raised to 0, Q raised to N minus R, that is half raised to N minus 0. This is greater than equal to 0.95. This can be simplified as 1 minus NC0 is 1 into half raised to 0 is 1 into half raised to N minus 0 is half raised to N. So this is greater than equal to 0.95. Therefore 1 minus half raised to N is greater than equal to 0.95. That is, now bringing this term to RHS and this to LHS, 1 minus 0.95 is greater than equal to half raised to N. So 0.05 is greater than equal to half raised to N. So 2 raised to N is greater than equal to 1 by 0.05, which is equal to 20. Reciprocal of 1 by 0.05 is 20. So 2 raised to n is greater than equal to 20. So we know that 2 raised to 4 is 16 and 2 raised to 5 is 32. So starting from 32, it becomes greater than 20. So for x starting at 22, x is greater than equal to 5, that is n is greater than equal to 5. This condition is satisfied. So the least value of x will be 5, which is option A. So for n equals 5, this condition will be true, that is 2 raised to n is greater than equal to 20. So the answer is A. A fair coin is tossed n times. Let x be the number of times head turns up. Probability of x equals 4, x equals 5 and x equals 6 are in EP. Then the value of n is what? So we have to find the n such that p of 4, p of 5 and p of 6 are in EP. So condition for EP is p of 5, 2 times p of 5 is sum of extreme terms, that is p of 4 plus p of 6. That is difference between p of 4 and p of 5, and difference between p of 6 and p of 6 and p of 5 will be same. So 2 times p of 5 will be p of 4 plus p of 6. So we have to find n such that it will satisfy this condition. So applying the formula, we'll get, now p is half, q is half, since it is a fair coin. So probability that heads turns up will be half. So this will be, now for this case, p raised to r, q raised to n minus r will be half raised to r, half raised to n minus r. This will be the same as half raised to n. So this term will be clubbed as half raised to n. So in this case, it will be half raised to n. That's it. So 2 times p raised to 5, p of 5 will be NCR, that is NC5. So 1 by 2 raised to n into 1 by 2 raised to n. Since we have simplified this, p raised to r, q raised to n minus r. So this will be 2 times NC5 half raised to n is equal to p of 4, that is NC4 into half raised to n plus p of 6, that is half raised to n into NC6. So half raised to n gets cancelled throughout the equation. So this will be 2 times NC5 equals NC4 plus NC6. So expanding the terms, so NC5 is n minus 5, n into n minus 4 into n minus 3, so on up to 5 terms. Similarly, 5 into 4 into 3 into 2 into 1. So this will be equal to NC4, that is n into n minus 1 into n minus 2 into n minus 3. So this is 4 terms. And this will be 4 into 3 into 2 into 1 plus NC6, so n into n minus 1 into up to 6 terms divided by 6 into 5 into 4 into 3 into 2 into 1. So we can see terms like n, n minus 4, n minus 3, n minus 2, these are common. It starts with, there's a correction, it starts with n minus 1, n minus 2, since we are decreasing it by 1. So this will be n minus 1, n minus 2, n minus 3, n minus 4, 1, 2, 3, 4, 5, and n minus 5. So we can see we have terms common such as n, n minus 1, n minus 2, n minus 3, and n minus 1 up to 4 terms, up to 4 terms. So first 4 terms are common throughout the equation. So this gets cancelled. Similarly, denominator for 4 into 3 into 2 into 1. This is common throughout the equation. So this also gets cancelled. So we are left with 2 into n minus 4 into n minus 5. This is only 5 terms, so this will be only n minus 4. So 2 into n minus 4 divided by 5 is equal to 1 plus n into n minus 4 into n minus 5 divided by 6 into 5. So now we substitute each of the option and find which of them satisfy the equation. We don't actually solve it, we solve it by substitution. So we found that for n equals 7, the equation satisfied. So the answer will be A, 7. Each of two persons A and B toss 3 fair coins. Probability that both get the same number of heads is, so we have n equals 3 for both of them, that is n1, this be n2 for person A and person B. Let this be let probability that A gets a head is x, and probability that B gets a head will be, so this will be probability that A gets an head, and this will be for B. So probability that both get heads at the same time will be P of x equals R, and probability is the same, so P of x equals R will be equal to P of y equals R. That is, both should get equal number of heads, that is at the same time. So if person A gets 2 heads, B should also get 2 heads. Similarly, if A gets no heads, B should also get no head. So total probability will be P of x equals 0 into P of y equals 0. Multiplication is for events which should occur simultaneously, and plus is for event which will be an alternate event. So probability that no one gets a head, so this will be 0 for A and 0 for B, plus probability that they get 1 head each, so this will be P of x equals 1 into P of x equals y equals 1. Similarly for all the 3 cases, that is P of x equals 2 into P of y equals 2 plus P of x equals 3 into P of y equals 3. Now we know that both should be equal, so these terms are equal, so we can write, let this be capital P, so this will be P of x equals 0 square plus P of x equals P of 0 square plus P of 1 square plus P of 2 square plus P of 3 square. Since both the probabilities are supposed to be equal, so now P equals half and Q equals half, since this is a fair coin. So applying the formula and taking out half common, we can say this is P raised to R, Q raised to n minus R, as we have seen in the previous sums. So this will be half raised to number of tosses are 3, so half raised to n, so half raised to 3, the whole square taken out. P of 0 is NC0, that is 3C0 square plus 3C1 square plus 3C2 square plus 3C3 square. So this will be half raised to 6 into 3C0 square is 1 square plus 3C1 square is 3 square plus 3C2 square is again 3 square plus 3C3 is 1, so this will be 1 square, that is 1 plus 9 plus 9 plus 1, this is 20, so 20 by 2 raised to 6 is 64, so 20 by 64, which is 5 by 16, which is option C. If x and y are independent binomial variables such that x belongs to B 5, 0.5, so nx will be 5, px will be 0.5, and for y it is ny equals 7 and py equals 0.5. 0.5 equals half, that is. Similarly for this qx will be half and for this qy will be half. We have to find the probability such that x plus y is greater than equal to 1. So x comma y should be greater than equal to 1. That is, the sum of x and y should be the value number of r, that is r should be, the sum should be greater than 1. So this can be written as p of x plus y greater than equal to 1 is the same as 1 minus p of x plus y equals 0, 1 minus none property. So in this case we can say x comma y, the total should be 1, total should be 0. So only possible way is both are 0, that is 0 comma 0. So this can be written as 1 minus p of x equals 0 and y equals 0. Only then it is possible that x plus y equals 0. So we can apply the formula. So we can say 1 minus p of x equals 0 into p of y equals 0. Since they are simultaneous condition, the both should be occurring simultaneously. That is, both should be 0. So we are using multiplication. So this will be 1 minus p of x equals 0 is, for this n is 5, so 5c0, p raised to 5, that is half raised to 5, q raised to n minus 5, that is half raised to 5 minus 0. Five minus 5, that half raised to 0, 5 raised to 5 minus 0. This is for x into, for this n is 7, so 7c0, p is half, so half raised to 0, this is q raised to n minus 5, n minus r, that is 7 minus 0. So this will be half 1 minus 5c0 is 1 and 7c0 is 1. So we can write 1 by 2 raised to 5 into 1 by 2 raised to 7 into 1 into 1. So this will be 1 minus 1 by 2 raised to 12, which is equal to 1 minus 1 by 4096. So this will be equal to 4095 divided by 4096, which is option A. Now this is similar to the previous sum, x and y independent binomial variables. So for this is A. So for A, nx will be 5, px will be half, and for B, ny will be 7, py will be half. So since px is 7, px is half, qx will be also half, and qy will also be half. So we have to find p of x plus y is equal to 3. So x plus y is equal to 3. So this is only possible if x comma y is 0 comma 3 or 1 comma 2 or 2 comma 1 or 3 comma 0. So these are the values for x and these are the values for y. So this will be equal to p of x equals 0 comma into p of x equals 3 plus p of x equals 1 into p of x equals 2 plus p of x equals 2 into p of x equals 1 plus p of x equals 3 into p of y equals 0. This is y, that's a correction. So p of x equals 3, x equals 3 into p of y equals 0. So we apply the formula. So as we have seen previously, p raised to r, q raised to n minus r, when p and q are half, this can be written as half raised to n. So for x, n is 5, and for y, n is 7. So each will be given as a half raised to n. So for this case, it will be half raised to 5, and this will be half raised to 7. So we can take this common from all the terms. This is similar to the previous sum. So this will be half raised to 5 into half raised to 7. We got this common from all the terms. We can solve it alternatively using the lengthy way. So this is 5C0, 7C3. Since for x it is 5, and for y it is 7, n is 7. So we apply the formula. So this will be 5C1, 7C2 plus 5C2, 7C1 plus 5C3, 7C0. So this will be half raised to 12, 35 plus 105 plus 70 plus 10. This is 220 by 2 raised to 12. So this will be simplified as 55 by 1024, which is option A. 10 coins are tossed simultaneously. Then probability of getting at least 7 heads is, so we assume the coin to be fair. So P will be half and Q will be half. This is for getting heads, this is for getting tails. So number of trials, that is number of coins is 10. So general formula will be P of R equals 10 CR half raised to R half raised to n minus R. This will be half raised to n 10 CR. So this is the general formula. So at least 7 heads. So this will be P of x greater than equal 7, which is equal to P of 7 plus P of 8 plus P of 9 plus P of 10. We take half raised to n common. N in this case is 10, so half raised to 10. So this we are remaining with NCR, that is 10C7. R for this is 7, this is 8, and this is 9, and this is R for this is 10. So this will be 10C7, 10C8 plus 10C9 plus 10C10. So 1 by 2 raised to 10. 120 plus 45 plus 10 plus 1. So this will be 2 raised to 10 is 1024. So 1024. Sum of this is 176. So answer is D, 176 by 1024. If a fair coin is tossed 8 times, then probability that it shows heads more often than tails is, now a coin is tossed 8 times, so n will be 8. So number of heads should be greater than tails. So it is only possible if let x be the number of heads. So if x is greater than or equal to 5, then it will be greater than number of tails. Since when heads will be 5, tails will be 3, when heads will be 6 and tails will be 2, and so on. So what we have to find is P of x greater than equal to 5. So first we write the general formula. P of x equals R will be, for a coin toss, this will be NCR, that is 8CR, P is half and Q is half for a coin toss, fair coin toss. So half raised to n, half raised to 8, half raised to 8 minus R, half raised to R, half raised to 8 minus R. So this will be half raised to 8 into 8CR. This is the general form. So P of x greater than equals 5 will be P of 5 plus P of 6 plus P of 7 plus P of 8. So this will be half raised to 8. We take this as common. So this will be 8C5 plus 8C6 plus 8C7 plus 8C8. Half raised to 8. 56 plus 28 plus 8 plus 1. So this will be 93 divided by 256, which is option B. If the chance of a gunshot hitting a target is 0.2, so P is 0.2, then so therefore natural EQ will be 0.8 since it is 1 minus P. So probability that at least 2 shots out of 10 will hit the target is, so what we have to find is out of 10 shots, that is n equals 8, number of trials will be 8, 2 should hit the target, at least 2 should be hitting the target. So X should be, that is number of hits to the target should be greater than equal to 2. So what we have to find is P of X greater than equal to 2. So this is the same as 1 minus null property. So this will be 1 minus P of X less than 2. So P of X less than 2 will be 1 minus P of 2 plus P of 1 plus P of 0. So general form P of X equals R will be NCR, that is 10 CR. P is 0.2. So 0.2 is 2 by 10, which is also 1 by 5. Similarly, this is 8 by 10, which is 4 by 5. So P will be 1 by 5. So 1 by 5 raised to R, 4 by 5, which is Q raised to 10 minus R. So this will be 4 raised to 10 minus R upon 5 raised to 10 into 10 CR. So this is the general form. So P of X greater than equal to 2 will be 1 minus P of 2 is, now we take 1 by 5 raised to 10 common into P of 2 will be 4 raised to 10 minus there's a correction, since we are asked for P of X greater than or equal to 2, so there won't be 2, so this term won't be there. So we'll directly start with 1 and 0. So this will be 1 by 5 raised to 10 for R equals 1. So this will be 4 raised to 10 minus 1 upon 5 into 10C1 plus 4C 10 minus 0 into 10C0. So simplifying this equation, this expression, we'll be getting 1 minus upon 5 raised to 10. We take 4 raised to 9 common. This is 4 raised to 9. So 4 raised to 9 into, so 4 plus 10. So P of X greater than equal to 2 was 1 minus 4 raised to 9 into 4 plus 10 by 5 raised to 10. This was 1 minus 14 into 4 raised to 9 divided by 5 raised to 10. That is 1 minus 14 by 4 into 4 raised to 9 by 5 raised to 4 raised to 10 by 5 raised to 10 divide and multiply by 4. So this will be 1 minus 7 by 2 into 4 by 5 raised to 10. Now it is given that 4 by 5 is 4 by 5 raised to 10. We are given that 4 by 5 raised to 10 will be 0.107. So multiplying this with 7 by 2 will be getting 1 minus 0.375 approx 9. So this will be 0.6241. uh, so this is equal to 1 minus 4 raised to 9 into 14 by 5 raised to 10. So in the options, 4 by, it is given in terms of 4 by 5 raised to 10. So we multiply and divide by 4. So this will be 1 minus 4 raised to 10 into 14 by 4 by 5 raised to 10. So this can be written as 4 by 5 raised to 10, and this is 7 and this is 2. 2 gets cancelled out. So we can see from the option it is 1 minus 7 by 2 into 4 by 5 raised to 10. So the answer is B, 1 minus 7 into 4 by 5 raised to 10. Numbers are selected at a random at a time from numbers 0, 0, 0, 1, 0, 2 up to 99 with replacement. An event A occurs if and only if product of two digits of a selected number is 18. If 4 numbers are selected, then probability that A occurs at least 3 times is. So now 4 numbers are selected, so n will be 4. So 4 numbers are selected, and if out of those 4 numbers, so these numbers are in two digit form. So out of these 4 numbers, if a number happens to have a product, that is if the product of the digits is 18, for example numbers like 29, 36, 63 and 92, in these cases the product of the digits, that is 9 into 2, 6 into 3, 6 into 3 and 9 into 2 is 18. So when either of these 4 numbers are selected, then an event will occur which is A. So if either of these 4 numbers are selected, then A will occur. So we have to find the probability that either of these 4 numbers are selected out of these 4 numbers, and this should happen at least 3 times. So we have to find the probability for that. So for condition for A is either 4 out of these 100 numbers should be selected, since the product of the digits is 18. So P, that probability, basic probability that a number is picked out of this is 4, that is 4 out of total number of numbers counted, taken out, that is 100. So P will be 4 by 100, that is probability of selection of these numbers. So this will be 4 by 100, that is 1 by 25. So therefore Q will be 24 by 25. So P is 1 by 25, Q is 24 by 25. So now number of events is 4. We have to find probability that A will occur at least twice. That is, when will A occur? When we select numbers out of this range. So we have to find the probability that X is greater than equal to 3, where X is probability that number is selected from this range. So when a number of selected from this range, A will occur, and this happens, if this happens at least thrice, then event A will occur at least thrice. So P of X greater than equal to 3 will be 1 minus, this will be P of 3 plus P of 4. That is, a number out of these 4 will be selected thrice, or all the 4 numbers will be from this group. So P of 3 will be now first we'll find the basic probability, that is general probability. So P of X equals R will be NCR, that is 4CR. P is 1 by 25, so 1 by 25 raised to R, 24 by 25 raised to N minus R, that is 4 minus R. So this will be 1 by 25 raised to 4, 4CR into 24 raised to 4 minus R. So for P equals 3, it will be 1 by 25 raised to 4, 4CR, that is 4C3, 24 raised to 4 minus 3, plus 4C4, 24 raised to 4 minus 4. This is 1 by 25 raised to 4. 4C3 is 4 and 24 raised to 4 minus 3 is 24. So 24 plus 4C4 is 1 and 24 raised to 4 minus 4 is also 1 since it is 24 raised to 0. So simplifying this, the final answer will be 97 divided by 25 raised to 4, which is option C. A boy is throwing stones at a target. Probability of hitting the target at any throw is 0.5. So P is given as 0.5. So probability of hitting the target fifth time at 10th throw is, so now we have 10 shots, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it should be such that fifth hit should be at position 10. So how do we find this is? Our purpose is fifth shot should be at 10th attempt. So first 4 can be in any order. It can be 1, 2, 3, 4, blank, 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 and 10th, or 1, 2, blank, 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 3, 4, etc. So the remaining 4 shots can be in any order. The order isn't necessary, but there should be 4 shots in 9 throws. So 10th will be a hit. So how do we find this is? P of four hits in 9 throws, that is probability that there will be 4 hits in 9 throws, that is this range, into since this is a simultaneous event, that is both should be occurring simultaneously, and into probability of at 10th throw. So this is P of 4 hits in 9 throws is the same as P of X equals 4 for n equals 9, that is 9 throws, into probability of hit at 10th throw is 0.5. That is probability of any throw is 0.5. So probability that it will hit the target at the 10th throw will be 0.5. So this is into 0.5. So this will be n. In this case it is 9. So 9 C4, probability is half, that is 0.5. 0.5 raised to 4 into half raised to 9 minus 4 into half. So this is 9 into 8 into 7 into 6 by 4 into 3 into 2 into 1 into 1 by 2 raised to 10. So this is 63 by 2 raised to 9, which is option B. From a box containing 20 tickets numbered 1 to 20, 4 tickets are drawn one by one. So n will be 4. After each draw, the selected ticket is returned to the box. Then probability that the greatest number on the ticket drawn is 15 is, so greatest number should be 15. So at least one out of the 4 will be 15. So probability that one card is 15 is 1 by 20. So probability of drawing 15 is 1 by 20, since it is 1 by 20, 1 out of 20 tickets. Probability of getting a number less than 15 from one draw is 15 out of 20, less than equal to 20, less than equal to 15. This is 15 by 20, which is equal to 3 by 4. So what we require is probability that the greatest number of on the ticket drawn is 15. So first will be probability that at least one number will be 15 into probability that another card will be at least 15 or less than 15. So this will be into 3 by 4 into combination of 4C1, since one card is drawn out of 4. One ticket is drawn out of a group of 4. So final probability is 4C1 is 4 into 3 gets cancelled. So this will be 4 into 1 by 20, which is equal to okay. So there's a correction. The required probability. Now we are selecting 4 cards. So the probability will be given by 4C1 into 1 by 20, which is the probability of getting 15, into 3 by 4 cube, since the other remaining cards will be either 15 or less than 15. So this will be 3 by 4 into cube because this indicates the remaining 3 cards. So answer will be 4 into 1 by 20 into 3 cube by 4 cube, that is 27 by 64. So final answer will be 27 by 320, which is option B. In a box containing 100 bulbs, 64 are defective. Probability that in a sample of 5 bulbs, none is defective is. So out of 100 bulbs, 64 are defective. So let P be the probability that a bulb is defective. So this is 64 by 100, which is 16 by 25. So therefore Q will be probability that bulbs are not defective will be 1 minus 16 by 25, which is equal to 9 by 25. So we have to find out of 5 bulbs, none are defective. So probability for a single bulb to be not to be defective is 9 by 24, 9 by 25. So this should be happening 5 times. Since none of the bulbs should be defective, so we'll multiply it 5 times. So this will be Q into Q into Q into Q into Q. This is the probability that none out of the 5 bulbs will be defective. So this can be written as Q raised to 5, which is equal to 9 by 25 raised to 5, which is option A. Items produced by a company are supposed to contain 5% defective items. So probability that a product is defective is 5%, that is 5 by 100. Probability that a sample of 8 out of a sample of 8 items, it will contain less than 3 defectives. So out of 8, at least less than 3 should be defective. Less than 3 products should be defective. So what we are supposed to find is P of X less than equal to 3, where X is number of defective goods, that is products, which is equal to probability of having 0 defective product plus probability of having 1 defective product plus probability of having 2 defective products. So this will be in this case N is 8. N is 8 since we are sample is 8 items. So this will be 8C, R is 0. So 8C 0, P is 5 by 100. So Q will be 95 by 100. So 8C 0. 5 by 100 can be written as 1 by 20. And 95 by 100 can be written as 19 by 20. So Q is 19 by 20 and P is 1 by 20. So this can be written as 8C0, 1 by 20 raised to 0 into 19 by 20 raised to 8 minus 0 plus 8C1, 1 by 20 into 19 by 20 raised to 7 plus 8C2, 1 by 20 raised to 2 into 19 by 20 raised to 6 plus, okay, that's it. So solving this, we get First we take 19 by 20 raised to 6 common. This will be 19 by 20 plus 8 into 19 by 20 into 20 plus 28 by 20 square. So this will be 541 by 400 into 19 by 20 raised to 6, which is option B.